Today, we're going to be talking about how AI-powered drones are poised to change the game for ship inspections and ship maintenance processes. So, first of all, I'm Marcus Rossi. I'm on our defense team here at Skydio, and I'm joined by a panel of four experts. We have Chris Stock, who's our Vice President of Mission Success for Global Government here at Skydio. We have Jake Johnson, who is our federal lead for the United States Navy and also for the Defense Advanced Research Project Agency. We have Jonathan Montague, who is our Solutions Engineering Manager and a real expert in photogrammetry, tremendous background. And then we're joined by Michael Cohen, who is the CEO of Key AI, which is an AI-enabled asset visualization platform that leverages drone-acquired data to enable remote digital inspections. So before we get much further along, I'd just like to point out that for all of you that have tuned in today, if at any point during the conversation you have questions, please feel free to post them directly on the platform, and we'll just engage and respond to them as we go along. So let me kick off with a couple points to really set the stage for our discussion. So I think we all recognize that we live in a world today where there's enduring and some would say growing tension between great powers around the world and a persistence of regional conflicts. And given that environment, military forces, military readiness is more important than ever, and particularly for the world's navies. And the navies face major readiness problems. So, as a point of example, we can look at the U.S. Navy. At the end of the last fiscal year, at the end of 30 September 2022, a year ago, 154 of 353 vessels in the Navy, which represents about 44% of the fleet, exceeded their 3-year material inspection requirements. And that alone is extremely concerning. But even to get to that point, the Navy Board of Inspections, Inspections and Survey, INSERV, had to conduct 80 in-service material inspections in that fiscal year, which was a 72% increase in total inspections compared to the previous 6 years average. So it's kind of a growing problem. And even with the 72% increase, you were still facing major delinquencies in inspections, to the point that the CEO subsequently came out and he's now made it mandatory, or she has now made it mandatory, that the Navy that INSERV conducts 102 inspections per year. So clearly that demonstrates how the cost in time and man hours to do these inspections is huge, and the Navy is struggling to keep up. And that's further demonstrated by the fact that, in a period where the Navy, along with many of the other branches of services, are struggling to meet recruiting goals, the Navy's authorized 99 new shorter duty billets to INSERV to try to fight that problem. So you're trying to make manpower, you're trying to put warfighters in the fleet, and yet you have to send more people into these inspection roles because of the size of this problem. So we think that that's an area that's ripe for a technological solution and data solution to ease the burden on those manpower and cost pressures that the Navy is facing. So we've talked about how the cost of doing inspections is huge, but the cost of failing to do proper inspections is probably even bigger. And the Navy estimates that the U.S. Navy estimates that corrosion alone is a $7 billion annual problem. So, that's exacerbated by that. That exacerbates, overall problems the Navy is facing. FY23 second half report to Congress highlighted that, major concerns with readiness, and for surface ships, they identified 14 functional areas that were evaluated as degraded. For submarines, it was 2 functional areas, and for your carriers, for your CVNs, 11 functional areas were evaluated as degraded. So we can see that the lack of inspections leads to this assessment of degraded readiness, and that can lead to unexpected failures and increased downtime. So when we talk about the financial impact, that's important, but I'd like to end my introduction with a reminder that the non-financial impact is delayed deployments, inability to complete missions, and degrading the defense of our nation and our allied countries' nations. So what's the solution, or what can be part of the solution? So we think that the use of AI-powered drones to inspect ships can pave the way for much more cost-effective approaches to combating corrosion. And not only that, they provide digital fidelity and full record capture of the inspection data that can be used to support kind of transformative and innovative efforts to optimize maintenance operations and improve readiness. Now, not any drone can do this, and the reason that we think that new drones are poised to do this is that drones must be safe. They must be able to, trusted by commanders to fly around very expensive equipment, complex environments around ships. And the reason that drones are becoming safer today is because of advanced flight control that leverages AI. So AI facilitates obstacle avoidance, which makes it easier for for personnel to be trained, any personnel to be trained to execute these previously complex missions. AI also streamlines data capture. That makes it so that anybody can do the task, and that the data capture can be utilized in forms and ways that support process and improvement flows and integrate with other technology that the navies are using for their maintenance processes. So in short, the integration of AI-powered drones in naval maintenance promises to kind of revolutionize the landscape for ship inspections and transform the way that navies conduct predictive maintenance. So with all that introduction, let's now get into the details. Let me turn it over to some of my colleagues here. I'm going to start with a question to Jake. So Jake, we know that the CNO's number one imperative is maintenance of ships. So help us understand a few things first to set the stage for our discussion. How has the Navy historically done ship inspections? How much time does that take? What kind of equipment is used to perform kind of the inspections in the historical ways, and where are we lacking data to improve processes and take these to a different level?
Thanks, Marcus, for the intro, and I'll kind of just real quickly cover an overview of kind of the Navy and kind of its inspection process. So the Navy is constantly inspecting. So, and what I mean by that is the ship and its crew are in this constant cycle of making sure that ship is ready to deploy and around the globe. So with that constant inspection 365, what ends up happening is there's a lot of redundancy there. So in going back on who is actually making and certifying these boats, you mentioned the Board of Inspection and Surveys, or INSURV. That was established all the way back in 1868. Now, moving forward, INSURV is still conducting those inspections it's supposed to be every 3 years. Right now, currently, they're on an average of 4.5. So we're already over by 1.5 years in those inspections, overdue. And COVID kind of led to a problem there. A downfall in Navy manpower kind of led to it as well. But as you mentioned, the CNO is increasing the amount of those inspections. Last year, they inspected 80 vessels, and going forward, the CNO expects 102 vessels to be inspected to try to make up for this deficiency. So how does a ship, just one singular ship, go through, let's say, a full cycle? They have an initial cycle in which the ship needs to pass its basic phase, its basic deployment phase. So the ship, gets everything ready. They're reporting up to the captain. Hey, these are the areas in which the boat needs improvements. These things are failing the inspection. These things are passing the inspection. This is where we anticipate, right? A lot of man hours, a lot of hands-on to make sure that they're getting ready for that basic phase. After the basic phase, they're going to move on to that carrier battle group phase and get it ready to deploy globally. And there's an additional, so it's going again. So right after they got done with the first phase, they're going to do it again. And a lot of it's redundant, again, like I talked about earlier. And then every 3 years, or 4.5 currently with INSURV, you're going to get that's going to get thrown on the captain, the crew, and they don't necessarily know when that INSURV inspection is going to take place. All these sailors have other jobs and duties on the boat as well. Many times on the vessel, they just completed an inspection and then they're right back doing it again. And this is because the information isn't being shared across the board and across the fleet. So after the inspections are done and INSURV has completed these inspections and certified them to deploy globally, that report goes to the Secretary of the Navy, and that's a written report. And that written report goes up to the Secretary of the Navy, who then reports to Congress. As you can see, a written report it doesn't really give you all the ins and outs and all that information. It gives you a good snapshot, but it's not it's very slow, cumbersome, and as soon as that inspection goes up for the annual report, everybody's working diligently to try not to get on the delinquency list on the following years. So if we look at how the Navy's currently conducting it, we can make small changes that will have exponential gains in improvement for that, like you kind of highlighted. Utilizing a drone system that is able to create that digital twin and create that that log of what the current status of the boat is. Now, instead of flying out multiple inspection teams, people flying across the globe, people doing it again and doing it again and doing it again, in only minutes, we're going to be able to fly a drone system, potentially use third-party software to analyze the boat and see if see what has changes, what is actually passing the inspection and what is not. So that was a kind of rough overview of the current state of Navy inspections.
That's great, Jake. And as you're talking, I'm thinking back to my time in the Marine Corps and being aboard ship and watching my counterparts in the Navy and the stress on those commanders to try to manage all those processes and keep the ship in a ready state. Let's talk about let's kind of talk about that last point you brought up. How the use of drone collected data can enable these remote digital ship inspections and improve these maintenance processes. Let me send a question over to Michael. So Michael, what are some of the things today that we could do to create better processes, efficiencies, and data improvement workflows that solve these customer problems?
Thanks, Marcus. Hello, everyone. Well, why don't I just jump in on what we're doing today? We're working with the Navy right now, and we're deploying Skydio drones to image the ship, and then we're pulling all of that data post-flight into our virtual inspection platform, Key, to do the corrosion analysis. And so I think, Marcus, I'll answer your question by talking about where this has traditionally been done, which is essentially teams of people walking around the ship with notepads. I think they've progressed to iPads or tablets now, but seriously labor intensive, really, really hard to document and look at all this sort of stuff. And then in the use case of ships, you've got to get to the outside of the ship. If it's at sea, that's virtually impossible. Other areas of a ship are really sensitive, really, really hard and dangerous to reach, like the mast that has radomes and other things. So it makes perfect sense to bring in some a remote sensing type of technology. There's other technologies competing. They tend to be crawler robotics, those sorts of things. But really, if you want to get a holistic look at the outside and all the parts of the ship, you need a drone, right? You need to be able to fly and what I call Superman around the ship. Reason why we brought in Skydio was it actually turns out to be a really complex environment, a ship. There are a ton of different areas that are small, that are very, very complex, ton of really sensitive equipment that's very, very expensive. There's a lot of guy wires and lines around it. One, to ask a pilot to do this would be incredibly stressful. You'd need an enormous amount of skill. You'd have to be an ace. You'd be over water all of the time. Sometimes, if you're not at pier, you would be entirely over water. So to ask a pilot to do this, having looked at ships and the ship structures, is nearly impossible. So you need autonomy to be able to do it. And if you've got something that's autonomous, then the floor of the operation rises completely. You're 10x faster, you're safer. You've got a small, lightweight, low risk drone that's now going to do the work of teams, right? And obviously, if you're able to get eyes on this, process it, put it into a usable package, you can start identifying areas that are safety risks, identifying areas that are deployment or operational risks, and start to understand the asset. In our case, it's Skydio meets Key for corrosion quantification.
And Michael, I think you've already done this with one of our key allied navies. We'd love to hear about kind of what you've done so far using Key AI and Skydio.
Yeah, sure. So this Navy put out a call for solutions. Corrosion's a huge issue. The ships are coming back from deployment. There's a huge demand right now globally on these ships, and they need to get in for retrofits and restoration and out as quickly as possible. As I said, crawler solutions, touch solutions like ultrasonic and those sorts of things. But we decided to bring in Skydio to autonomously fly the ship. And if I didn't say it, by the way, the ability to train up a sea person very quickly on a system like Skydio, where you don't need years and years of experience, and have that unit at sea with people that know how to use it is a key value prop here, right? You can't move around ace pilots everywhere. So we brought in Skydio. We're a technical partner, so we ingest their data, process it into a 3D digital twin, and then we connect 3D to 2D, deploy algorithms for corrosion detection. And I'd like to show you this staining as well, which is a byproduct or precursor to corrosion, but quite an interesting AI problem. So let's play a video here. If you could we've got an example here we can bring up. We've got a tech person, Marcus, working in the background, and I don't see it. So just pause there for a second. Let's pause. Okay, cool. So Marcus, there's a bunch of data management and user management in the platform that we love to show, but we're not going to show because this is sensitive data. So we're going to start just in the inspection app in Key. It begins with the digital twin. This is Skydio acquired data that we've processed into a digital twin. It's XYZ functionality. We use it as a navigator for situational awareness, but more importantly, to allow the user to zoom in on the digital twin and access the 2D data. So we can play this. Marcus, I've got it zoomed out a little bit just to keep it a bit anonymous for what ship it is. But the user would click on the digital twin. It showed location of where the photo was, location on the 2D, and then our approach is to work in 2D entirely, nondescript part of the ship. And we begin by leveraging the user. Let's pause there. So what we've done here is allow the user a tool to be able to zoom in, locate this corrosion, and then Key will automatically segment the corrosion. But what we're seeing here, if you want, let's play. The user can then manipulate that segmentation, get it as tight around that problem as we possibly can. Hit save, record it, send it off for training. And then we've got that location on the digital twin and that location in the 2D. Let's pause for a second. Here's an auto detection algorithm deployed because we want to use the user to identify these things, but then we want to get really fast on this. So we want to deploy automatic detection. So here the user simply clicked a button, says, show me all of the corrosion, and Key's gone and lit up all those items of corrosion. And then the user is very much in the loop. So the user can decide to save it, reject it, move on. So let's play this. And then what we also work on Navies, let's pause, is what's a really interesting problem that we're really proud to tackle is staining oftentimes, or corrosion oftentimes, is sort of a dirty orange. Dirty orange could be life preservers. So it's a really challenging problem. And it's almost always accompanied by staining. So we're working on algorithms and deploying algorithms to detect only staining. You can see on the bottom right of the screen, there's a bunch of runoff that'd be on the ship hull. It's really important to understand that that is not corrosion. Something looks like corrosion, but it's staining. We can play this through. Great. I think we've got it there. Thanks so much for the video. And then Marcus, you can imagine what happens. With all your corrosion, you quantify it, you build a database. From a database, you build a report. It's a cloud-based platform. So now you share it with all your teams. You repeat a flight once the restoration on coatings or mechanical repair, nuts and bolts are replaced, you need to go back and verify that. Out goes Skydio, flies it again, new data set to compare old versus new. And that's what we do in our partnership with Skydio.
Yeah, Jonathan, thanks for walking us through that. That was really informative. Sorry, Michael. I was about to introduce Jonathan here. That's why I threw his name out there. But yeah, so as I was listening to you talk, Michael, it's really clear that the quality of the data is critical. And if you're going to replace humans with the drone data that's feeding into the inspection software, it's got to be top quality data. So that's why I would like to introduce Jonathan at this point. And Jonathan, can I turn it over to you to kind of walk through how the drone captures that data and how we can do these repeated inspections much more effectively and efficiently?
Sure. Yeah. Thanks for the intro and thanks for the walkthrough, Michael. I mean, I always like showing the end result when you're talking about drones because it's not about flying the drone. And I think that's what Skydio does really well is we take an approach in our systems, with hardware and software and autonomy at all levels to enable the pilot or the operator to not have to think very hard about flying a drone, really thinking about the mission success, in this case, an inspection of a naval asset. We have obstacle avoidance. We have, different modes that allow, users to do inspections, efficiently, effectively, and repeatably, and really safely as well. I know safety is a big topic in taking the user out of harm's way. And you can see in, some of these images here that the drone basically deciding how it's navigated around a structure in order to capture this data. And that's, our 3D scan product that is a part of, what you get with the Skydio package, which includes 3D scan. As you can see in this one, we're near a very complicated object that's very difficult to inspect manually and honestly with a drone. Even if you're a good pilot, I mean, I'm sure there's some pilots on this call, this webinar, getting close to an obstacle, whether it's energized or complicated or magnetic, is you have a red flag in your head as a drone pilot. Traditionally, with Skydio, it's not an issue. We don't rely on magnetometers in this case. We're using our vision system, creating an awareness map so the drone knows what it's doing while it's collecting data. In this case, it shows you the workflow of 3D scan. We have this radome here, and we're basically creating a bounding box at 3 dimensions. And then the drone basically decides, okay, I'm going to fly around. I'm going to figure out the best routine for me to capture this data. And then it captures the data, and you can see the AR overlay there. And in this case, though not a Navy vessel, it's a very, it's an odd shaped structure. It's big, it's large, it's expensive, very similar to Navy situations and vessel situations. This type of inspection could take 4 to 5 man days and up to $15,000 to $20,000, and we did it in a quarter of an hour with about 200 photos, which then informs the photogrammetry model, the 3D model, the digital twin, and the 2D elements that you need for the AI elements that Michael's team is doing. Some more examples of end results of 3D scan here. So, the ecosystem of Skydio goes from the hardware all the way through the end result of, the data outputs. Data quality is paramount in these processes. And we've made it easy on the complex structures you see today, which is, most structures out there are complicated. It would be great if everything was a cube, but they're not. So yeah, that's kind of the breeze through of how Skydio makes things a little easier for pilots and operators to maintain assets.
So I'll pass this question to Chris. Chris, if we were to do these scans at predictive intervals, what does that do to open up, to kind of evolve how these maintenance processes work and maybe, streamline process flows or create new efficiencies?
Yeah, so I'll hit it up front and then pass it over to Michael to give his perspective as well. But I think what Michael and Jonathan showed were more reactive type inspection scenarios where we're going out and we're inspecting an asset right now. I think what we're able to provide with data acquisition, data storage, and being able to look at scans over time is to look at things upstream. If we're talking about ship maintenance, which we are in this particular webinar, how that could impact maintenance cycles, maintenance procedures, different paints or coatings that we could put on the vessel. So we're able to do scans, whether it's month over month, week over week or day over day and conduct that same scan anchored in time and space in a predictive nature over time. So Michael, I know you showed, your ability to detect corrosion time now, but maybe talk about with some of the interactions and discussions you've had with the Navy of how we could improve processes upstream so that we can combat corrosion earlier on, either in the maintenance or shipbuilding cycle.
The things that we hear a lot are, first of all, when the ship's deployed. It's great when it's back at base. You can do a lot of work. You take a look at it, and you get a lot of insights into it. But as Jake said, you are right up against a deadline. At that point, you're very taxed on labor, perhaps even labor shortage. You're looking to turn around and get back at sea. Ships are a lot like airliners. They're just not, when they're in the hangar, they're not great. When they're at the pier, they're not great. They need to be deployed. So moving that timeline backwards, in which you're getting as much information prior to reaching port, is really, really valuable. So immediately deploying at sea would be a huge value to be able to look at this sort of stuff. And because, if you were, X dollars, X number of people, shut down zones to be able to look at this every time, you just don't do it. It's prohibitively expensive. You don't have the manpower. But if you make that very cheap, very easy, then you now have the ability to get multiple temporal data sets over time. And then once people like us get that sort of stuff, we can look at rates of change. You can understand where your problems, you're in the green on something, you're going to yellow, you're in the green on something, it's going to jump right to red. And you're starting to feed this information in. And once you tell the people who know how to fix these things, look, this thing's growing. They do amazing stuff. I mean, now that's like magic insight into it, and just everything gets better. I hope that's clear.
Oh, Michael, that's great. I'm going to pose a question here. I'm not seeing. I'm going to pose a question here that I think is on the minds of a lot of our naval leaders, especially some of our more senior naval commanders. Is how do we feel? How can you feel capabilities like this at scale? Like how do we ensure that these drones and these capabilities are built? They're fielded with built-in cybersecurity, secure supply chains. They protect the information about the ships and the condition of the ships, and keep that information out of the hands of our adversaries. And Chris, I'd like to start with you on this question. If you could talk about that a little bit.
Sure. I think what we're talking about here is inspecting or flying around critical, expensive, and sensitive assets. So I think number one is reliability and safety. We talked about safety a lot during this discussion in terms of what autonomy and AI enables for safety of flight. But I think reliability of the systems in the hardware and software, that it's going to perform day over day the way that it's intended and expected. So I think reliability is number one, and something we take seriously and build into our products as a kind of founding standard. Ease of use. So I think we talked about that as well. John highlighted that in his 3D scan demo, but we've really tried to take a lot of the guesswork out of being able to conduct these complicated scans over critical or complicated structures, and building in more intuitive and automated workflows that make it easier, on an untrained or non-professional pilot to be able to scan and evaluate and assess these complex structures. And then the third about securing data. So the way our X10D product is designed, all of the systems are air gapped, so they do not communicate over the air. Your system is secure and safe. You own it. You own the workflow. You own the distribution. You own the post-processing. So we've really built security as a kind of prime leading factor for how we've designed our system, specifically for our defense and government customers, knowing they want to retain either sensitive data or don't want it vulnerable to other people seeing that to scan or evaluate these critical, expensive, and sensitive assets.
Yeah, thanks, Chris. Michael, is there anything you want to add to that from your side? with your software?
Well, I won't comment on this security, but the way I think about this, and this may be the drone industry, but the way I think about this is a commanding officer who's chiefly responsible for everything on the boat, including catapulting fighter jets off of it, landing them, helicopters off, which is all incredibly dangerous, complex maneuvers. And the first drone inspection where the drone crashes into the deck, I'm willing to bet he says, no way. They say, no way, forget it. We're not using that tech. And they take, and they deal with these complex things. So reliability is huge. These are sensitive areas. And I think the audience and the market has very little appetite for failure when trying this new innovation.
Yeah, and it's interesting you say that, because that is a repeated thing we hear from customers across the defense space. Our aviation customers, we use Skydio for aircraft inspections in similar ways, and they, those customers on that side of the in that domain and on the surface and up in the air, they're very concerned about the very same issues that you brought up there. I have a question here that's come in from one of our viewers, and this is really for you, Michael, at KAI. Obviously the inspection, the ship condition inspection, includes the submerged portion, which the drone can inspect. The question coming in from the audience is, can your platform incorporate other submersible images along with it, images from submersible inspecting assets along with the drone images for a 3D of the entire ship?
Thanks, Eric, for the question. I'll be super quick. Today, Key incorporates above the waterline data, generally from drones, not always, but generally from drones, and combines single beam sonar. So if you wanted to inspect the pier that the ship's attached to, sonar below the water gets combined with Skydio data above the water, and now you're looking holistically at the structure. Ships are a little bit different. We think that there's an opportunity for video in the future, but sonar so far doesn't provide any value to the hull of the ship, but we think video will.
Awesome, thanks, Michael. And we have some more questions coming in. I'm going to start with Jake on this one, and then Michael, you can weigh in as well. But we have some questions about can these type of scans be done while the ship is underway? Can you do these at sea and then send the information forward maybe to your first maintenance contact point to kind of be more timely in your reaction? Jake, you want to answer that first, and then maybe Michael, you can add a little bit.
Yeah. So the short answer from like a 3D scan digital twin while the boat is underway, not currently. But how I've answered this question, over the last few months with a number of people in the Navy is, what current assets do you have available to look inward on the vessel? And really it's just human eyeballs. And something that was always brought up during my time in service, which is, hey, you're going to have to do more with less. And that was always, to me, a complete oxymoron. But now when we start talking about utilizing the advancements in technology like Skydio and Key AI, is you can actually now do more with less. So you can get a twofold capability by utilizing the drone system, and turning the sensor on the boat itself to give you a real quick snapshot that could be streamed the feed directly to the commanding officer or those critical decision makers. From a technical aspect, I'll kind of kick that over to John or Chris.
Yeah, I mean, I can add a little bit to the underway nature. It's an active area of investigation for us. It's particularly around, we call it dynamic, but moving vessels and doing scans and things like that nature. We do have features right now on our systems, Scout particularly, where it is kind of like a virtual tether between the operator, the controller, essentially, and the drone, which makes manual scanning, manual pictures or videos taking a lot more seamless in moving environments. And I know there's certain folks doing inspections that way. So we definitely have ways, and there's ConOps and ways we can help you determine how to the best utilize our systems for this. But we're actively looking at ways to improve our systems as well for these sort of inspections and operations.
Chris, do you want to add anything there?
No, I think John hit it. I think we have the ability to do, full motion video or still inspection right now. And we're looking, on kind of our technical roadmap of how we would incorporate more automated workflows, similar to what John showed in terms of how we utilize 3D scan on static objects right now, and being able to do those same sort of automated workflows while the ship is underway. So it's an active area for investigation for us, but it's knowing it's a tech gap that we need to figure out and close out.
Yeah, I think it's just one of the exciting things about a company like this with the way the engineers work is folks like Jonathan and your team are constantly talking to the customers and these areas where they want improvements to the capabilities, and we're constantly bringing those into the roadmap to pave the way for the future. Michael, do you have anything you want to add there, or should we move on to the next question?
Well, underway is moving. That's, depending on what your mission, still photos, I suppose. Video would certainly be possible. Building a digital twin, I think, is probably quite challenging underway, but I'd make a distinction between underway and away from port. So all of this work could be done while the ship's away from port. Key has a desktop app. We can imagine a laptop on site, Pelican or a Skydio case, Skydio drone, these combined out of Wi-Fi, no internet connection, and operating just fine to get the mission complete.
Awesome. Thanks, Michael. Thanks, Jonathan and Chris, for elaborating on where we're going with that capability. Some questions about battle damage assessment, kind of on the same related topic. Obviously, a big area of focus in the Navy. I'm going to turn over to you, Jake, to maybe talk a little bit about maybe what that could look like as we go forward.
Yeah. So the Navy is entrenched in tradition, which is great. Like, I'm all about tradition, keep things the same way, but at some point, things have to progress towards the future, and the future of some of these technologies like we're talking about. So if we were talking about battle damage, right? Let's use that as an example. If you're on a boat and and the captain needs some critical information, individuals are going to go out there, your sailors are going to go out there, your ensigns are going to go out there, your lieutenant JGs are going to go out there. And they're going to come back and come up with the information and that request for information and whatever's going on with that boat. Now, this is now just word of mouth. These are eyeballs, people looking at it. I think it's this. That person thinks it's this. At the end of the day, the officer, whoever the junior officer is there, is going to go back to his office, and he's going to type up a report, and that's going to take some additional time. He's going to type up that report, and that report's going to go up to the commanding officer. The commanding officer is now going to take a look at that report. He's going to review it, and he may or may not agree with what's in the report, and he might ask for some more information. And meanwhile, days are going by, right? And so you can see where this is adding up. We don't know the current status. The last thing you want to do is that the captain is so frustrated that he's going to walk his own body down to figure it out for himself. In the world of where a picture is worth 1,000 words, like, this is exactly that. Show photographs and actual imagery to the people immediately so that they can make critical decisions on what needs to happen next, and then spread that information across the battle space so that everybody is informed. Too much time is going to end up going by in these critical situations, especially if we're in peer competition, and God forbid that any of our vessels are actually hit or critically damaged with a number of Americans or Canadians on board. Like, this is not a room for there's no room for error here. We need to be able to get that information really quick. And meanwhile, FYI, all these sailors during the situation during this time period are manning battle stations. And manning battle stations means they are at a critical position within the boat to maintain its security and protection. So you can see how quickly a situation like that could add up. But the use of artificial intelligence on board platforms like Skydio is is a no-brainer.
So clearly, based on our discussion thus far, pier side inspections, huge potential for cost saving, man hour saving, cost savings, process improvements for navies around the world. Port inspections in port while you're underway. Just as again, you don't have to be with the drone aboard. You don't have to be the drone and the QAI software aboard. It's a game changer to have that capability to speed up condition-based maintenance and maintenance processes while underway. Future use cases with battle damage assessment. Jake, do you want to talk about any other use cases that the small UAS might provide for ship commanders once you can trust that drone around the ship and the AI enables that safe operation by less skilled operators?
Yeah. Obviously, we want to talk about where the Navy's investment and our tax dollars, where it's going, these very expensive platforms. We want to have those eyes looking in. But now when we actually start thinking about other use cases, and especially with the delivery of our new platform, our X10 platform with these upgraded, gimbals. So, with a FLIR boson plus thermal camera, a 64 megapixel, a 30x zoom, super impressive on a Group 1 platform. Now, instead of looking in at our critical infrastructure, let's turn it to an operational use case here. And let's turn the eyes out of the boat. And now I'm looking at maritime interdiction, hey, what's on board that vessel? Do we need to launch VBSS crews to go and interdict this boat? Before I start putting people in a very vulnerable position and riding on small boats, slapping around in big waves up against a vessel that could be potentially armed, hey, I want to make sure that captain has that information. Are these people armed? Do they understand us? Well, the great thing about the X10 is now we have these attachments on here where we're going to be able to put a speaker on there. We're going to send that over there. We're going to have that thermal imagery and see if these individuals are armed. We're going to be able to have two-way conversation with this vessel. And now you're taking the temperature down in a potentially very dangerous situation to save American lives. And then on top of it, if we even talk about man overboard, if a person falls overboard at sea while deployed, the chances of that person dying or never being found again within the first 2 minutes it's over. So within 40 seconds with our new platform, we're going to be able to get this system up in the air. And so these watch standards, if that's in their safety kit, they throw up a Skydio X10 Delta, immediately send it out to where they think, start scanning with that FLIR boson plus and looking for that individual. On top of finding the individual and where they are, you're going to have cursor on target of location of that individual to know where they are and immediately pass that to the captain. And then you're going to also be able to ensure that who is in there. So one of the biggest problems on board the boat, if someone goes overboard, is a muster. Understanding who actually even went overboard on the boat. The captain doesn't even know. If it takes 15, 20 minutes for them to even get a head count on the boat to get it to the captain. So this is just information. Who is it? So now you have a 64 megapixel camera zoomed in on the guy who went overboard, and we know that it's Seaman Timmy. So we know it's Seaman Timmy. He's the one in water. We know, hey, do we know if he can even swim? Hopefully he can swim. He's in the Navy. But, these are just some of the things that just, I think that if we can save American lives and take the asset, not only looking at our critical infrastructure, but looking out for operational use cases, I definitely think Skydio's in the ballpark there.
Yeah, thanks, Jake. That's perfect. This next generation of drones that's coming out, the next generation of technology that's coming out, we're in the AI revolution right now. The new drone that Skydio is releasing, X10D, has incredible processing power aboard with the same lightweight capability, and I know Michael is working on the next generation of his product. So that's kind of, I think that gets us all excited. What you just talked about there, I'd like to talk a little bit about that, since this future is here. It's coming very fast. These are not distant capabilities. So Jonathan, you want to talk a little bit more about what that X10D is going to bring? I think Jake alluded to several of the key capabilities already.
Yeah, no, thanks. And Jake hit it on the nose. I mean, it's a stepwise and generational leap in capability across the board. I think some of the key points, that relate to this use case and the naval use case is it's IP55 rated. So in light precipitation and in adverse weather, we can operate now. The the optics are much improved, as Jake mentioned. We have inspection gimbals and ISR related gimbals for the front payload. So it's a bit, we can swap those in limited capacity there. And then we're very modular in the sense that we have additional payload capacity and additional payloads. Jake touched on the speaker mic and the spotlight. We also have an RTK module, which can help at, with accuracies, especially when in dock for inspection and photogrammetry applications. And we're operating 24/7 now. So what that means is we have our night sense modules that allow us to operate at night around obstacles, just like we do in the day, which is, for rescue situations and SAR situations, like Jake was mentioning, could be a game changer for folks that are, overseas or need or overboard, and need, rescuing. So we have a lot of capability. It's hard to talk on in 30 seconds, but it's just really taking everything we do at Skydio and just making it 10x or x10, I guess.
Yeah, thanks, Jonathan. So, Michael, with all those new capabilities, where do you see that opening for you? And maybe you want to talk to our viewers a little bit about where you see your platform going in the future, and kind of how you see yourself solving even more solutions for the Navy or for navies.
Well, one of the things that I want to make the point, Marcus, that navies are pulling in this technology. I think in drone sales, if it's infrastructure inspection or whatever the use case, there's been a lot of push into the market. This is very, very much a pull by navies and armed forces for this kind of the adaptation of commercial technology particularly around AI. Look, the X10 for us, if you give us precipitation, it's all about deployment, right? If you can do it in a little bit of rain, you can do it in a lot of wind, and you get really, really compelling imagery, then it's a complete game changer. We like to say if a human can see it in the image, we can build AI to detect it. Well, when you're flying around a ship or a bridge, in 10 knot winds, getting that crisp image so that you know exactly what you're looking at is very, very challenging. And so you really up the sensor. We're into this whole new world of really, really deep data in terms of resolution. And that means everything will be able to be seen and identified now. So you name it, if it's corrosion on a ship or attachment points on the radar dome, okay, let's build the AI and go find it.
All right. Thank you, Michael. Well, we only have a few minutes left here. I'd like to kind of go around the room here real quick, just for any final comments from our panel. Any last things you want to share with the audience, areas you're excited about, maybe some opportunities in the future to really tackle these corrosion problems, these inspection problems across the Navy. Let's see. I'll start with Jake here. Jake, any final comments for our viewers today?
Yeah, I would say, kind of just summing it up is, like you kind of hit everything with the current global state of, geopolitics and everything that's kind of going on. What has really led, the Department of Defense is our Blue Water Navy and our control of the sea. And we need to remain that way. And you kind of highlighted some degradation in capabilities during some of these inspections, which is concerning. The number of shipyards over the years has decreased. Our capacity for manpower to be able to keep up with that demand. So this is a pressure cooker for sure. And Skydio is definitely not the solution to all of those things, but I think the quicker we tackle this problem and jump on board digitalizing some of things that took many days and or weeks and or months to do, it would just increase that efficiency and safety, and make sure that our U.S. Navy and our ally navies are at the tip of the spear, per se. So definitely think that there's a lot of promising things here in the future, and looking forward to what's next.
Awesome. Thanks, Jake. Just seen a really interesting comment here on our board. We were talking about the other use cases, the man overbuild drill, and like we've all done the old way where you had to muster and identify the person. But that two-way speaker attachment that the X10D provides, you could possibly, if the man overboard can speak, you could possibly identify that individual way quicker. So just one example of how the technology simple technology can change the game. So Jonathan, you want to add any final points here for our audience?
Yeah, I think we covered most of it. The one comment I'll add is that, Skydio is obviously dedicated towards inspections. One of our core use cases, you can go to our website and see it, is critical infrastructure across industries. And being a dual use company, that means we get to learn from customers across the world and use case, applications of our technology across the world, which really helps inform these and doubles our investment in essentially these types of use cases for critical assets like Navy. And that's probably one of the most critical assets we have. So lots of learnings gone into X10 and just our whole product stack. And I think, we'll continue to develop and push the limit of what you can do with these small UAS. And always interested in hearing customer feedback. It's part of my role. So, keep the questions coming and feel free to reach out.
Thanks, Jonathan. I'll turn over to Chris for final comments. Chris?
Yeah, kind of piggybacking off what John said. I mean, we're talking about ship maintenance and inspection today, but there's a lot of parallels across the department and government for just kind of dull, dangerous, and dirty jobs, where we can augment or now bring in automated workflows and much more pristine data for things that were done using manual labor previously that are very timely or dangerous to do. So I think when we're talking about ship inspection today, but there's a lot of other parallels where we can do the same solutioning and problem solving for other use cases within the government, and we're here to kind of help service that.
Awesome. Thank you, Chris. Michael, I'll give you the last word.
Pleasure. Two things come to mind, Marcus. Around Key, we like to say that AI won't replace you, but someone using AI will. So if you're not believing yet, I suggest you take a hard look at it. And secondly, and I hope everyone appreciates this, we work on corrosion and concrete problems. We work with drones. And I know that, the latest aviation fuel or wind farm gets a ton of attention environmentally, and so it should. But our work, we see it as, if the bridge can be preserved, if the ship can be at sea longer, if people can be safer, then this is a great mission to be part of. And I see our work as playing a small role in that, but an important one and an increasing one.
Thanks, Michael. Well said. I completely agree. So with that, everyone, thanks for joining us today. That's all we have. And we really